share my screen. So today we are going to talk about too many things. Yesterday we discussed till this, I believe we did. We also had a very good coverage on S3, right? And how to work with different commands of AWS S3, all that, and creating buckets, deleting buckets, and playing around data, all that stuff. Okay, adding or removing data, everything, friends. Okay, so now after that, this is a beautiful topic for sure. I can tell that because in industry, this is the most happening scenario. What is that? Let me. Okay, this is from here. We have to keep starting. Okay, so now before I close this windows, I just would like to show you because I almost terminated all that to show you a fresh start. See, you can see here, like, these are all different instances while I do testing. Okay, while implementing load balancing, you can see here, this is from one server, this is from one server, and you can see the output here. You can see, okay, this is from other server. Now they were not available. I terminated all this so that we can do a fresh creation of everything. So when you do that, the load balancing occurs. This is a small URL. You try to hit to this website. So when you hit this time, of course, it won't work. None of these are running. So instead of one server, the same load is balanced among the kind of auto scaling we do. I did two more additional servers so that it is more to that. I'll explain everything with diagram and everything in detail so that you understand what is load balancing and auto scaling and how we implement that in AWS. We see all that and how same thing can impact in industry because we are working in a billion-dollar company, right? So multi-billion-dollar company. So definitely we use so many servers and lakhs of people will be working in our company. So definitely as ours is a bank, right, we need too much, we have too much of information that to it is top 3 or 4 bank in US. So you can understand how much. And we are DevOps engineers. So definitely we manage at least 10 to 12 dev teams and there will be a lot of data that is being loaded for all that. You got it right. So you understand the kind of this thing we have. So I can easily get this. I can tell that this is one of the most important scenario, especially when you are a cloud engineer or a DevOps engineer. Okay. So now anyhow. So but of course we don't need to worry. So when you get into that, they'll tell you what to do, how to do, take up all that with the requirement. So now I think we started recording, right? Yes. So what is load balancing? Let me explain this with a simple example before I get into the steps. Okay, steps part is simple, but before that, let me just make you very much comfortable with the topic first. It's a very simple topic, friends. Suppose you can take any example. You can take real life example or you can take any websites example. All of you are aware of websites, right? So what we can do, we can take a simple example. Suppose you have a server. Okay. Assume that it is a learning server itself, and then you have data inside that. Okay, this is a learning server. Let me name this as a simple, or otherwise, let us put it as some movie server. Okay, and then obviously inside a movie server, what is that we have? We have movie data, and then right, what happens from the outside, there will be number of users, right? User one, user two. Okay, likewise, user three. It's going on. This will infinite users. Like that means you might have thousands of users or lakhs of users or crores of users for this movie. Like you say Netflix, you say Amazon web service. I mean, sorry, what is that? Amazon that that video website, and then one more is what is that famous one? There are many. So Hotstar. Okay, assume that. So if it is one server, what happens? These many users, what they try to do, they try to hit for this server. Okay. So now when user are hitting this, as number of users increases, what we call that as, it's called as users connecting to the server. It's nothing but simply we call it as load. Right? The name, if number of users connecting, we can call it as a load or hits, or you can name it as you like. As number of users increase, load increases, right? Because our topic itself says load balancing and auto scaling. What is that load? Load in sense, like this scenario is applicable everywhere. And what is load here? Load in sense, like number of users trying to connect it to a server. That server can be a movie server, it can be a learning server, it can be some other server. Okay. So now point is simple. As number of server users increases, load increases automatically. When load increases, the immediate impact is the response time or latency might increase. You got it right. This is the real challenge and real problem. Everywhere, this is everywhere. Not just for us, the problem is our website will sometimes might be little slow. The response you don't get message, usually it should get in some milliseconds. That message might be delivered in a minute or just after 5 minutes. So that is actually low latency, right? Means you are not providing response as user is expecting. Why? Because all that load that is needed, you are managing using one server. Then what happens automatically when the number of users increases, automatically this load balancing is going to impact or affect. So this is the best, this is the scenario. Now, what do you do right now? How you are going to leverage this? Simple, right? What is that? You add two more servers or three more servers, or how many other servers you want to balance this load. You got it right? What do? You try to add one more server. Okay, based on load actually, that you understand if you work in some kind of environment, you don't need to worry much about it. And you added one more server. Assume that we added three more servers. Sorry, one actual server and two servers for balancing load. You got it right. So now how many servers are there? We have server two. Okay, and similarly, we added one more server, server three. And this data is distributed. Whatever data is there in this server, and this data is distributed into server 2, and same data is distributed into server 3. Now, when a user make a request, if this server is busy, right, then automatically what happens, that there is something called in the middle between user and between this all this system at server side, right? This is at server side. Okay. Very interesting scenario if you have curiosity to understand load balancing. Between these two, what happens is, what do we have is we have something called, what is that something? This is called load balancer. So load balancer. Now what load balancer will do? Now actually you think that this, when you try to connect it to some website, you are thinking that you are directly raising a request to the server. But in reality, what happens is your request is sent to load balancer, and load balancer will see the load, like how many users are connecting to this. Actually, this user request first go to load balancer. Okay, and then this you can take this as one service. You don't, if you ask a question, Manoram, what is this? This is a service. Most of these are services in this kind of environments. Okay, you don't need to think that everything is a service except users. Okay. So now what happens when users try to send a request? First, it comes to load balancer. Load balancer understands how many requests are coming from server one. It knows how many requests are coming. Not for server one, sorry, let me reframe. How many requests are coming from users? Based on that, what it will do, it will redirect either to server one or either to server two or either to server based on the load. Suppose server one is already servicing some 100 requests. Assume that. And the limit you put is some 100. Okay. Then automatically it will redirect it to server 2. Similarly, you put this is servicing 200 requests. Then this is also overloaded. Then immediately load balancer will redirect to this server 3. Okay. Likewise, what happens? That load is distributed. Now, some other extra servers coming might hit load balancer. User doesn't know you because all of them have same URL. Keep that in mind. I'll show you all this with proof and practical example. But when we hit based on the load, this load balancer decides which server that request should be serviced. So, or to which server that request should be sent. That is decided by the load balancer. Got it right? So, in this way, what happens? You should understand one thing. What is that one thing? Your load is distributed between these servers. Again, you ask me a question. Suppose users keep increasing rapidly, what happens? Then automatically you add more servers, right? That is what right distributed mechanism is. So most of these technologies, cloud computing, big data, data engineering, all this will follow this strategy. What is that strategy? Distributed computing. So as and when you need more nodes, automatically we will increase the nodes. And for that, that's what auto scaling is about. Got it right? Now, we'll come back to that again, that point again. But now I'm talking about load balancing. So this is how the load is distributed and machines are added. That adding that machines and removing machines to this cluster is auto scaling. Right? The next important step is what is that? So how load balance happens, I'm explaining. At the same time, to balance this load, we need to implement a strategy. What is that strategy? Auto scaling. Right? Let me just add that point here itself. Auto scaling means, as name says, what is that? Adding. It will automatically add servers to the cluster and it will automatically remove servers from the cluster based on the load. If load is more, it will add a node to the cluster. If load is less, it will remove a node from the cluster. Simple as that. And that is done by a mechanism called auto scaling, which is another strategy of this load balancing mechanism. You got it right. Now, this is all about simply speaking, what is load balancing and what is auto scaling. And we see all this with practical steps. When you see the steps and when you see the testing, you get a clear idea how this load balancing is happening, how this auto scaling is happening. Everything will be in detail discussed. Understood now? Auto scaling, it's a very simple thing. As the name says, it helps us to increase number of server instances or decrease in number of instances based on the load, number of requests coming from users. That's all. Right? That is done by taken care by who? That adding servers or removing servers. Adding more instances, removing instances is done by a mechanism. That mechanism is called auto scaling. I hope all this introduction is clear for all of you, right? Because this terminology, all this will help you a lot, friends. And if you understand this example, that is much more easier for you. And I believe I just used very simple language, but the technical terms I put as is most of the time, so that it's easy for you while implementing your AWS load balancing and scaling. Okay, and before I jump to the actual steps, I just want to give you one live example, one real life example of load balancing and auto scaling. Right, you can take many examples and you can assume many examples. I'm moving to the next slide. Okay, I'm just closing this one. Is that fine for all of you? Fine for all of you, friends? Okay, if you are clear, then I'll just jump to that. Then let me do one thing. Let me move to the next window. So a real life example. Suppose the best thing is you have gone to a hotel, right? And you want to dine in that hotel. What do you do? First, you go to the manager, right? All the people will directly go to the manager, right? That's what they do. So this guy is the manager, right? Assume that. And you are the user one, assume that, user two and user T. Like this, there are so many people coming to the hotel. And how many, generally everybody will try to connect to the manager, which is a load balancer. Now behind manager, who will be there? There will be servers. Right? The real example. Servers means for each one table or two tables, there will be, right. There are tables here, multiple tables like this, 1, 2, 3, 4, something like this. And similarly here also there will be tables for dining. Assume that. Don't worry about the beautiness of diagram. Understand the concept of the diagram. Okay. So similarly for server 3, there will be some tables assigned. You know this. This is a practical scenario. Right, friends? Suppose right now. Let's start. You just start. The dining just started. Then people are coming. First, they assign all these people to one server, right? Server 1. Suppose if this guy is full now, all these tables are full. Then what happens? All of you know now. This example should just give you a very simple understanding of load balancing. Then manager don't again assign the users to this server. Then what manager do? Manager will now assign users to server 2, right? Then automatically, and till this server 2 is busy, overloaded, right? Not overloaded, loaded, is busy with all the tables. All the requests go to this server 2. Now again, what manager do? Again, he will assign the users to the server 3. Likewise, if you remember this example, that is the best example of load balancing and auto scaling. I'll talk about how auto scaling happens here. Okay, again, server 3 is assigned, likewise server 4, server 5, server 6, something like that. Now what happens? Let's talk about auto scaling. Right? Once you assign a table to user, right? And then that user completes his dining. Automatically, what happens? That data is deleted. Data in sense, I took the technical word. All that plates are cleaned and that table is ready and ready to service for other customer, right? Then that is what, and again that is kept into the pool now, and this can be used. This empty table, it can be used for some other user, right? Now automatically what happens? This is informed to the load balancer that this is free. Then he will assign some other user to this table. Likewise, you can think this as the purpose of this over means automatically that is again it is returned back to the pool. This is no more needed, then it is returned to the pool so that it can be reused for some other service to service some other request. Got it right? This will automatically happen. What is that? Assigning tables and cleaning up and again giving up to some other new customers happens strategically. There will be someone who will be taking care of all that. Got it right? So, and here in this scenario, both loading and auto scaling happens together. Got it right? So this is a real example. You can just keep this in mind to understand the concept of this thing. There are likewise you can compare this with many real life examples. You got it right. So I just took one. You can assume or you can check for many examples. Okay. So now getting into this, let's talk about this. Now you understand this easily. You don't define it difficult. What is load balancing or auto scaling? What is load balancing? Simple, right? It is a process of distributing incoming network traffic across multiple servers to ensure no single server becomes overwhelmed or overloaded. That's what we discussed, right? In the last two examples. And those examples should clearly give you an idea. Yes or no, friends? So most of you also might have this idea because you might be working in some kind of IT related areas, right? So that's the idea. Now, these are the important points, advantages with load balancing and auto scaling. What is that? Now, as we talk about load balancing, these are the key points. What is that? The advantages ensures high availability and fault tolerance. And suppose among 3 servers, if one server is gone, still remaining 2 servers keep servicing the other incoming requests. So there is something in industry, what we call, especially this is applicable in DevOps and big data and site reliability engineering and then data engineering, all this. High availability. Always your resource must be available. Resource in sense your server or node must be available. Data must be available. So with this mechanism, load balancing mechanism, your data is always available and server is always available so that we are at high fault tolerance. Fault means having some issues. Fault tolerance means handling such faults, right? So that is the advantage with load balancing, high availability and fault tolerance. And it also improves application performance and reliability. Definitely, right? When you have that load balancing mechanism, you can distribute load to some other servers so that the performance automatically increases, right? So that is the advantage here. Redirect traffics automatically if one instance fails. Suppose one server is down for some reason, immediately all that traffic is redirected to some other server so that the service doesn't disrupt. It is not going to stop. It continues as usual. You got it right. So, and finally, what is that? So here in EC2, this is commonly used with multiple EC2 instances. In AWS, we apply this scenario with EC2 instances in different availability zones. If you ask how, we'll see that with example. And this is the example of a simple diagram of what is that load balancing. You have users making requests and that request go to load balancer and that load balancer distribute this request to either server 1 or server 2 or server 3, which we discussed in the diagram just few minutes back. Is this clear for you, all of you? What is load balancing here? Right? Simple, right? It's just managing the load and distributing it to different servers across a network within that cluster. Got it right? So that is the idea. Next one. And how load balancing works. It's a simple scenario, right? By now you should get an idea, right? But still I want you to get that into your mind, okay? So how it works? An user sends a request to your website or application. That is the first thing. Anyhow, all of us know that. That is the first step anywhere. Then what happens? There will be load balancer, which receives all these incoming requests. By now you should understand because we have a very detailed discussion in diagram. It intelligently distributes traffic among healthy servers, which is nothing but here it is in EC2 instances. If it is our environment, it will be nodes. Nodes means data servers. You got it right? So that is the idea. And if one server goes down, traffic is redirected to other healthy servers. Healthy servers means working servers. Just keep that in mind. Okay. Ensure seamless user experience with zero downtime. This is very important. Suppose you go to a movie, suddenly there is a power cut. What happens? How is your feeling there? And you are watching your favorite hero's movie, right? How do you, and we can understand the frustration there. Even same happens with users who is trying to connect to different websites for information. So that's why generally in real time, when you are running any websites or web development applications, always we should ensure that those are available and then we don't have any downtime issues. This is very important. Even if you have downtime, that should be somewhere around in the midnight, just in some time brackets, not all the times. Okay, you have to ensure that customer service is not interrupted. That is very important. You got it right. These are the steps, and I'm very sure you understood these steps here. How load balancing works. An example you can see here. If 300 users visits your site and you have 3 servers, then automatically each server handles around 100 requests based on that load. Got it right? So automatically there will be better service and faster service and better customer satisfaction. So this is idea, friends. Next one after that. And types of load balancers. You can see all this in the AWS window, right? When we are implementing all that, following the steps, you can see different load balancers and which one we should choose all that. So these are few of the load balancers, application load balancer. We use this only, ALB, network load balancer, and then gateway load balancer. So these are the 3 different load balancers we have in AWS, or one more is there, I believe. We'll check that. Okay. So, and we generally use this ALB, application load balancer. We don't need network load balancer or gateway load balancer for now for this demo purpose. Okay. Next after that, sorry. Next after that is what is auto scaling? We'll just finish this discussion and then we'll go to the practical implementation. Auto scaling is again simple, right? It's just a feature or a strategy, AWS feature that automatically adjusts the number of EC2 instances in your application according to demand. Okay, so you don't need to do anything there. Once you set up this auto scaling, that auto scaling automatically takes care of adjusting number of EC2 instances, adding additional EC2 instances, or deleting, not deleting, but reducing number of EC2 instances is taken automatically taken care by this auto scaling feature. So what is the advantage here? You are dynamically managing the load and everything and requests, right? So also you are also efficiently utilizing resources. You got it right. How we are efficiently managing resources? We are adding EC2 instances only when it demands, not all the times. But we don't do that. Auto scaling feature will automatically takes care of it. You got it right. When there is a demand, it increases number of EC2 instances. When there is no demand from users, no extras requests are coming to some particular resource, then automatically it will reduce the usage of EC2 instances. So that is auto scaling, and it is a feature we enable that. And how to do all that, we see that stepwise in few minutes. And key points with auto scaling ensures optimal performance during the high traffic. Optimal means best performance. Reduces cost by terminating unused instances during low down demand. So this is taken care by who? Auto scaling. It just terminates if a EC2 instance is not needed, so that you are not paying any extra money for that. And maintains application availability by launching new instance if one fails. Suppose there are 3 or 4 instances in your cluster which you created for your application purpose. Then automatically what this auto scaling feature will do, it will immediately launch new instance and divert the traffic to the new instance. That's why in real time there is this replication factor or this kind of things. Minimum 2 is required. You got it right. Auto scaling capacity we call here. That capacity at least we put 2 instances. You know why, friends? Because if one fails, at least there will be one more which is doing the service. You got it right. So anyhow, you can also do all this practically in our AWS this thing. Okay. Now next, use auto scaling groups to manage instances. So there is something what we create this ASG auto scaling groups, and we attach our instances to this auto scaling groups, friends. Got it right? That is the idea. This is overall idea about auto scaling, and we just gone a little bit more into that information there, right? Okay. So this is about load balancing and auto scaling. Now, how auto scaling works? So this is nothing but this talks about how you define this auto scaling and how it works here. So here just now I discussed, right, minimum number of instances. If you want to enable this auto scaling feature, at least having at least minimum number of instances, if you set it to 2, it's a good practice. Maximum, it's up to you. You can put 3 or 4 or 5 or 6 or anything, but 2 is the ideal number. Okay, anyhow, it depends on your need and necessity. It's up to you. Okay, but I'm just giving you just an ideal this thing here. And desired capacity, all that we can see there while creating through that window navigation. Okay, and scaling policies. Scaling policies means based upon your CPU usage, memory usage, traffic. Based on that, you can choose what is that, when to use new instance. You got it right. That is scaling policy. Suppose if your CPU usage is 70%, then you have to assign a new instance, new EC2 instance, or you have to start a new instance. Suppose your memory is occupied with some, okay, 20 25 TB or sorry, GB or something, not TB, GB. then you have to start new EC2 instance. Likewise, you can customize your requirement in this auto scaling feature. You got it right. That is the idea, friends. Now, when demand increases, then automatically auto scaling launches new instance automatically. When demand decreases, auto scaling terminates unnecessary instances. Okay, somebody can you please mute your machine? I don't know. Okay, so we're going in a, it's fine. Next. And finally, what is that? This auto scaling feature integrates seamlessly with the elastic load balancer to handle new instances dynamically. Okay, both work elastic load balancer and this auto scaling groups, they work together to handle all this traffic or load which is coming to your servers. Got it right, friends? I hope this is clear for you now. You should be very clear with it with the number of times I am repeating all these steps. And finally, what is that next example scenario? Right? How this, I mean, load is distributed among your servers, among your instances. Suppose morning, if website traffic is low, then you just keep one instance running. Afternoon, traffic is high, everybody is awake and working, then automatically launch two or more instances. Night, generally, everybody after 6 or 7 people slowly keep going to the home. So automatically traffic decreases. Then what you have to do? Terminate extra instances. Of course, you don't do that. Auto scaling feature will automatically do that. So this is the example scenario. You got it right? Okay. So next after this example scenario is fine. Next one, real world analogy. Like, the best example, load balancing, like a manager dividing customers among 3 counters in a restaurant. Auto scaling. What is this auto scaling here? Opening or closing counters depending on the number of customers. You got it. Sometimes I visit some hotels. They don't allow me to go into certain rooms and they say that, sir, these are closed for service. No more service is happening in those rooms. They say that. Have you ever came across such situation? I quite often see such scenario or experience such scenario. You got it right? So everyone sees that, right? This example gives you a real world analogy. I put all this because more than practical part is not difficult, but understanding the, the technology behind that is important, right? Understanding concept thoroughly is important. Friends. Just remember. Finally, this is the summary load balancing purpose, distribute traffic evenly, and that is done by elastic load balancer. Auto scaling automatically adjusts number of instances, and that is done with the which EC2 AWS service EC2 auto scaling. Combined, what is that we are going to achieve? Smart, scalable, and cost efficient infrastructure. You got it right. This is what we are going to achieve. Right? Does this make sense now? Is this clear for all of you? Did I make it simple and easy, or did I make it little confused or tough, complex for you? Can I get your answer from the chart? Okay, it's good. Then that's fine. So idea is making it simple, friends. Okay. Anyhow, so that's why we try to have this. Now goal. What is the goal? We are done with theory. Now we understood what is load balancing, what is auto scaling, right? We don't need to go too much into that detailing. This summary slide itself says what is that load balancing, what is auto scaling, and we have a clear explanation with 2 different diagrams. So that should also give you a clear picture. Now the steps becomes very easy for you. Okay, so now you can see. Let us see. Now what is our goal? Let's create a web app. Okay, web application, simple web application. We don't build too much. We don't need that, but let's create a simple web application runs on EC2 instances. Let's put that web application in EC2 instances. And then what is that? We try to balance load using a application load balancer. And automatically we'll also add auto scaling groups. and then we'll see the behavior. That's all. And we'll test it, and we'll understand that with the testing, right? How this load balancing and auto scaling is going to work. Is that clear for all of you now? So let's start this now. Already I have most of the things. I did everything, but I closed it. I terminated all that because I just want to again do it from the scratch so that you understand it very clearly. Okay, I terminated most. These are the actually the auto scaling instances. I just added enabled auto scaling, then it automatically increase number of servers to 2. That because that is the capacity I added. I'm just giving you a on-fly information. Okay. But anyhow, we'll do that now. So it's quite easy steps. If you just follow these steps and just observe what we are doing, it is so simple again, right? So what do we do is, why don't we do something from the scratch? Let's create an EC2 instance and name it as my web server. If somebody named it, we'll change it. That's all. Okay. So what do we do right now? Create a web server, an EC2 instance and put some name. If not web server, you put whatever you want. And then what is that? Make sure you allow, this is by default, it will be enabled with port 22 SSH, and also enable this HTTP port 80 so that you can access and test it from outside the AWS account. Okay, got it right? So let's do that now. Go to the root. You have to log in from the root user. Understood, right? I don't know if we can make this clean and simple. Yeah, everything gone now. Now this seems to be a bit good. It looks clean now. What is that I'm going to do? First, I'm going to launch instance. I'll start from here. I just say something like my web server, but this will be already there. Okay, somebody would have already took this. So probably I doubt if this is allowed, but let me just go ahead. And then, write all this. So this is all again the routine steps we follow while creating instance. So I created name, I provided name, choose Amazon Linux. It's up to you which one you want to choose. I generally choose this for my learning and demos and also my analysis purpose. You got it right. So I use this. So of course in office you don't have a choice. You know, right? Most of you know that we have to definitely work on those environments. But here in AWS, it's up to you because you are the owner, right? So you can do what you do. This is your playground. Okay. So choose this and then what? Go to this and always use free type. That's best for you. Unless if you think you have a sufficient balance in that account, it's fine. Okay. And key value pair, which one you want to choose? Choose existing one and make sure that that key value pair is saved in your somewhere in your local machine. Else again, create a new one. That is the best thing. Okay. So if you don't have it, create a new one. If you have it, just add that existing one. I have all this. I am just adding my from key one. Okay. If you want, you can create it. And I have explained all that clearly in my previous videos, in previous recordings. Maybe in the second recording, I explain how to create this key pairs and how to access, right, using SSH. I did discuss all that. Maybe you can go through that recording. I'll share all recordings in the group so you can go through that. Then after this, what? So you can just choose existing security group. You don't need to create again one more security group. Okay, this is fine. And all this is attached, like, HTTP and SSH, everything is attached to this security group. So you don't need to do anything more right now. Especially I don't need to do because it's my mission, right? So I don't need to do anything extra. But if you guys want any help or any this thing guidance, you can screen share and you can ask me. I'll help you with that. Okay, that's not a big problem. Help is always there. So now finally, what I have to do, friends. So that's all right. I don't think this. This is the storage. We have 30 GB available for free users. So you can just use that 8 GB as is. That would be fine. We don't need too much of memory here. Okay, storage for our playing around all this. Okay. And finally, what is that? Launch instance. I think I did add, I didn't update this subnet information, I believe. So you have to add subnet too. That is also important generally. Okay, go to the instance. Let's see. So one thing I didn't update is I just kept subnet as is. Where is that? You can see here. I choose default one. That's fine. But generally you have to add this subnet. That's a good practice. Okay. So what I can do is I can. So we don't need to worry, right? Terminate this instance. Not a big deal, right? I'll just show you one more time. What is there in that? Once because you can play around as many times as you want. Okay. So it will automatically shut down. You don't worry. So you can go there and instance, launch instance. I'll just go a little faster this time. And I just name this as my web server. Okay. And then choose this. And then also you can choose AMI image, whichever you want, you can choose. We have two free tier images available. And then after that, choose existing key value pair. I choose my PEM key one, and then here edit this. I think I forgot to edit here. And subnet information, you can choose anything. I generally prefer, you can see here. Anything is fine, friends. I choose one A. Okay. And finally, select existing security group and then choose anything of your choice. I choose my NaomTech as security group. And all these are fine. And then now launch instance. Now I did created everything properly. Now successfully created. You can see here. And finally go to the instance. Now, where is my instance? This one. Running one is my instance. You can see. And just refresh because this status check should be successful. You can see here. There will be two status checks. We should get a 2 by 2 successful here. Of course, it will work. We don't need to worry. It takes a couple of few seconds. That's a lot more than that. Okay, and then if you want, you can select it and you can verify it. And then if you want to check status and alarm, still it's initializing the system status checks here and the instance status checks. Okay, it's going on. So once that is done, what is that you can do? You can refresh it. So creating instance is over. That is the first step. Okay, and that's what this guy asked us. And it should have this security group HTTP enabled just to hit that server or instance. So that's why we are enabling HTTP 80 port. Okay. Now you can go and check that also. Suppose you can see, select this and then go to that security group there. And you can see what all protocols enabled here. You can see two protocols enabled. One is this, I think both are TCP only. We need HTTP, friends. Okay, what we have to do right now then? So you have to go to that security groups there. Okay, and then edit inbound rules. Oh, you have HTTP enabled, no problem. Okay, HTTP is already there. You don't need to worry. If it is not there, try to add them. That's fine. It's not a big difficult task. It's a very simple task. If needed, we can do it even when on demand. Okay, we don't need to worry now. So that is okay. So step one is completed without much time, without taking much time. Let's go to what step two. So as we are testing a web application, what we have to do, install a simple web server. And these steps are very simple, friends. Just copy and paste. That's all. You don't need to do anything. Okay. If you want, I can share this in our this thing. If you want to do it, try it right now on fly itself. Do you want me to share it in the Teams chart? Shall I do that now? If you are trying, I can share you. So you can ask me anytime if you need anything, any resource. Just ask me, friends. Unmute or just type in the chat box. Okay, now once your instance is started, what is that you have to do? Just go to the instance back again. EC2 instance. Select on instances. Okay. And refresh again. Initialization should pass that security checks. That is important. So you can see 2 by 2 checks passed. Okay. Otherwise, it means there is some issue with your instances. Just keep that in mind, friends. Okay. But most 99.99%, you don't have any issues with this. Your instance will be just created without any problem. Now select this. Now, what is that we need to do? We have to follow, we have to implement step 2, install a simple web server. To do that, you have to connect it to that instance. What is that I should do? Connect it to the instance. To connect it to instance, just select this checkbox of that instance and then just say connect. And then here you just need to click on this connect button. That's all. Then we connect it to the EC2 instance, which is nothing but my web server instance. Now you are here. Now what is that you need to do? Simple. You have to follow these steps. So what is that? First thing, just need to update your Linux environment. Okay. Sudo and then paste. Okay. It just checks the status of your Linux operating system. There is some error. Usually it won't show that error. Sudo m update. Okay. Let me try this way. Let me get to the root, and from root, let me just type these steps, test these steps. Okay. So this has to go actually. Of course, we can run without this also. MetaX checks. Okay, no match for argument Y. Okay. Generally, this works. So let me do one thing. Let me try to install this. If it is working, it's fine. We just need to install this HTTP server. That is enough for us. Okay, perfect. It's installing. We don't need to worry. Generally, it just only, this is a sanity check. This first one, you don't need to worry much about it. Now we install this HTTP server. You can see it's complete. It's perfect. Now what is that now? Just start that. Right now we are in the root, so you don't need to do anything. If you want, you can directly say sudo space and then that command. That's another way of installing this web server. Okay. And then just start it. You can see that started. And if you want to see the status, if it is started or not, you can just come here. Instead of start, you can say simply status. This one. Okay, just enter. And you can see here, you should see active and running. You can see that. Understood now? So it's running. We don't have a problem here. So again, let me try again. Usually it shows bit in color, but some reason it's okay. It's fine. This it's optional. So we are saying enable HTTPD means this web server instance. Suppose you don't need to come and again restart it once you shut down your machine and when you restart. So this automatically enables your HTTP server, but it's up to you if you want to enable or if you don't want it, it's up to you. And right, if you are not getting output or if you are not able to get the result from web server, you can come and check the status and then start the server. That is the sanity check you should do when you are working with in a real environment. Okay. So that is fine. Let me clear this. Now this step 3 is also complete. Is it clear for all of you friends? Step 3 is also done. Next after that, what is that we should do? And now create a simple HTML page. Generally, this HTML, you can create big website or small website in that server. Okay, but for our testing purpose, we don't need to be web developers. Just simply use this, okay? Because it is only for understanding AWS, right? So let me do one thing. Just take this, just simply create this inside that instance. Okay, you can see here. Just paste it here and then press enter. Automatically by default your HTML, all your HTML code sits under this path where www and HTML. Okay, it is done. So if you want to go and check that, suppose what is your present working directory, home EC2 user. Now by default, if you, this is actually your web page path, default web page path. We generally create all our web pages under this path. Okay, till HTML it is built in, and that index.html, all these web pages would be created by us in that folder. Okay, so for HTTP server, if a website should be automatically accessed, suppose you want to access a web page or web application from a HTTP server, then all your files you have to keep in this path. So if some user hit it from outside, automatically it will try to come to this path and pick the pages from this path. That is the FYI, important information. Maybe if you ask me why you keep HTML file in this path, Manoram, if that is your question, because when some user hit a request to the web application, web server, sorry, this web server, EC2 instance web server, then it will go and look for that web page in this path. What is that path? Where www.html. Okay, and that index.html can connect it to many other HTML pages and many other JavaScripts. You can add too much of information there. It's like how you organize is a different story again. It's a development process. Okay, so that is, you got it right. Why this path means this is the default path. When some user hit a request, your web server search for that request in this path. EC2 instance web server. Okay, so now you can go there. So you can see, let's do one thing. Let's go cd where. Again, if you want, you can see what is there inside where. You can see these are all here. And if I can say ls-l, it comes like this, line by line. Okay, then we have to go to cd www and then cd. Maybe you can just check what is there in each subfolders. You got it right. If you are curious, you can just use this ls command and list out what is there in each folder. It's up to you. Okay, right now I am in www and then finally HTML and then ls. And we just created index.html. By default, this path, you know, right? What is that? This path where www.html doesn't have anything. All that web pages, everything, you have to build it. You have to build that. Okay, you don't have anything pre-existing there or ready-made there. You got it right. Who has to build? Either developer or whoever it is. Or you, as a cloud engineer, you have to deploy. Suppose a web developer developed all that, and we should allow either developer to deploy his or her project into this path, or you have to do that otherwise. Any one of the two process. You got it right. So now what you have to do, when you say ls, you can see that index.html, and then now you can just view it saying cat command. That is one thing. You can see this is just added by us only, right? You can say I copied this and added. Suppose you ask me, so I want to edit this, can I do that? Yes. You can say vi and then just say index.html. Suppose this is coming from where? Hello from EC2 instance. What is that instance name here? That instance name is my. Okay, so here escape. Why it's not allowing me means you have to use certain commands in this VA editor. Say escape and then press I. That insert mode allow us to type or edit this file. Okay, and here you can just add my web server. Okay, and then escape and then what is WQ here? This is nothing but save and quit. Okay, if you just say quit, it won't save. Done. Now you can just, for quick checking, you can use cat command. Again, you don't need to use vi command. Okay, right. So this is there. You can see now web server is updated. Now we understand when we hit this web server from outside using URL, then you understand from where this output is coming. You got it right. So this is idea, friends. Okay, next one. Similarly, next we are going to the next step. So we did this. Of course, we built two more web pages once we add that dynamic instances. Okay, I will discuss that with you. Now after that, step 4. What is that we should do right now? We should create something called AMI template. Okay, we created AMI image, that is okay. Now we have to create an AMI template. Don't get confused between these two. And what is the purpose of AMI template? If you, again you ask a question, right? Always you have a question, why or what? Answer is simple. We will this as a launch template for scaling. You got it right? We use this as a launch template for scaling. Just a minute, friends. 1 minute. Sorry, friends. I just need to interrupt. So this is step 4, friends. Okay. So there is a difference between AMI image and this. Okay. So what is that? It's very simple again. So to create this AMI template, what is that you should do? Let's follow these steps. It's very simple again. Okay. Go to that instance you created. This is the instance, right? And then what is that you have to do? You have to go to actions and then you can see here, right? Can you see image and templates and then create image and you just take some name here. I just copy the same name. Okay. So again, if you want, I can again repeat this. Shall I repeat or is it fine for you, friends? Do you want me to repeat? What is that step 4 we should for step 4? What is that we should do? We should create an AMI template. For that, it is simple. Already you have instance running, right? Go to the instances. Let me repeat it so that it's easy for you. Then select that, check this, automatically go to actions. And here you all that whatever needed to update on instances, you can add under actions. And you have image and template. Right? Simple, right? It's a navigation, window navigation, and simple, straightforward. And then create image, just provide name here, image name. Okay, because the purpose of this is for auto scaling. Okay, this is needed for auto scaling, friends. Really important. Okay, really important, but not difficult to create, but very simple to create. So what you have to do, just give any name. It's not like it should be my web AMI, not needed, friends. You can give any meaningful name which you remember, which it is understood by you or your team. That is important. Okay, my web AMI, that is fine. And here I don't think you need to provide anything else, friends. Okay, so that's all. And then create image. That's all, friends. No more checks are needed. You don't need any additional checks, just create image. And then that task is over. Step 4 is completed. Just leave it aside. And if you want to check if that images are created properly or not, you can where you have to check for that. You have to go to images. Under that, you can see here AMIs. And now you can see my web AMI. And still you can see that it's in pending. If you see here, the status is still in the process of creating. Can you see that, friends? Okay. So let it be there. We don't need that immediately. You can just leave it, just leave for it. Okay. Now that is step 4. Now what is that I should do? Go for step 5. Create a launch template again. Again, if you ask me, that's why I made these slides very easy for you so that even later, if you want to understand, slide will just quickly explain what is that. Okay. Next step is creating a launch template. This template defines how new EC2 instances will launch automatically. You got it right? So let's see that. If you go and check in the window, you can easily understand that. So the purpose of creating a launch template is what? This template defines how this EC2s will launch automatically. Got it right? So what are the steps we should follow? Simple, right? Again, very simple. Go to console, launch templates, and then create launch template and just add these details. We have to just add these details. One is we have to provide template name, just copy that. Again, these are user defined. Okay, which are user defined? This one, this all this name, but this AMI is something which we just created. And this is independent of instance. You can use it for other instances as well. Okay, got it right. So I'll just show you now. You can play around later as well. Okay. So now what is that? You have to go to launch templates. That is here. You can see here under instances. You have launch templates. Okay. And already I created one. Okay. So what I am going to do, I am going to create one more just for testing for today's application for this new instance and to show you as well. Okay. I put this as my last web template 2. And then what all details we have to provide here. So next after that, so we have to choose this my web AMI. So where is that? You can see here. So now once you provide name, scroll a bit down and you can see my AMIs. Okay. And you can see just now we created this. Yes or no? Just now we created this. You can select that. Okay. Automatic, it's by default selected. You when you say owned by me, it is automatically selected here. Just change that selection, that's all, friends. You don't need to do anything. So what are the steps we have to follow? Provide name. Second step, choose AMI image template. That's all. What Amazon AMI image template we should choose. By default, we just have one we created. Just that is when we just change that selection, automatically it is selected. Next, after that, what else do we need? Instance type. You can see here, right? The next step is, third step is instance type. We have only one free tier eligible, that is t2.micro. Select that. Okay. Then key value pairs, right? Key value pairs, you know, right? Already you just saw that my PEM key, I choose this. Whatever you created for instance, same you can add it here. Shall I repeat it? Whatever you created for EC2 instance, key value pair you created for EC2 instance, you can add the same here. That is fourth step. Okay, and then what else you need? Networking, this thing, subnet information. Okay, subnet you can choose. You can see here. Again, I am choosing here as usual my favorite zone 1A. Okay, it's up to you, friends. It's not like you should choose 1A. It's up to you. Okay. And then availability zones, you have so many, but I choose this one. You can see here. So you just need to add this networking settings. This is step 5. What is step 5? Choose subnet, any one of the available this thing. And then what is that? Availability zone, I choose 1A, US East 1A. And then security, I choose existing security group because there are so many in my machine created. If you want, you can create a fresh one. It's up to you. Okay. So next after that, so I choose my NaomTech security group. Okay. And this is one more thing you need to do. And finally, what else I think we are almost done with the steps. I'm just again summarizing what are the steps you need to do. We have to follow 5 or 6 steps. What is that? Provide name, step 1. Step 2, choose the AMI template. So, okay, that is step 2, owned by you. Next one, step 3, instance type. Choose instance type. Step 4, add the key value pair. You can generally use the key value pair which you created for your EC2 instance. Okay. Step 5, update the network settings. Okay. Subnet information and availability zone and then security group. Okay. And finally, what you have to do? I think we did add all other things, and storage volume you don't need to change. By default, it shows 8 GB, GIB, not GB. GIB slightly little bit extra than GB. Okay, because for us every day I do conversion between GB and GIB, but I don't want to get into that now. Okay, so we have 8 GIB, just leave it as is. Don't make any changes. And finally, what you have to do? Just check the steps if we followed everything properly. Yeah, most of this is perfect. And finally, what you can do? I do this SSH and HTTP. Anyhow, we have enabled in that group. That group has both. We don't need to do anything extra now. Finally, create launch template. Okay, finally we are done with another step in the process, step 5. And now actual real steps came. Of course, the previous steps are not, don't think they are unreal. Without them, we cannot build this step 6 and step 7. You got it right? So till this, it's clear for all of you. Next, what is that? Let's create an application load balancer. You know, right? With all that discussion in the first 40 minutes, we spoke too much about load balancer. All that load balancing happens with the load balancer. Now we are creating that. It's very simple. What you have to do, just go to the, again, EC2, and here scroll it down. You can see here load balancing. Under that, there are load balancers. Okay. So just select that load balancer. And nothing is there here. So what I am going to do right now, so create load balancer. Under that, choose application load balancer. I just copy this, my web ALB. ALB means application load balancer. Okay, you come here, nothing is there. So what you have to do, create load balancer. That's all. Now you can see number of load balancers available. Right? By default, we choose the first one, application load balancer. Based, suppose you need network load balancer, you choose that for your application. If you are doing it for your team purpose or for your organization purpose. But for now, for our demonstration, this is enough. For our testing application, because web server is a web application, right? We are going to run a web application. So I choose application load balancer. So finally, you can say create. What you can do among these three, sorry, we have to choose application load balancer. Just say create. It gives you a couple of again input. We have to fill in these inputs and load balancer name. Just paste it my web ALB. You can name as you like. This is user defined. Okay, so it's you don't need to stick to this name. And then internet facing, yes, you have to keep that as is. IPv4, again, you have to keep that as is. And then network mapping, you can see here. VPC, you can use default. You don't need to change this. And you can see here availability zones. At least choose one or two availability zones. Okay. Okay. I choose 1A, 1B. It's up to you. We have 5 or 6 availability zones. You can choose any one of these, any 2 of these 6 availability zones. You don't have any this thing on this. You got it right. And finally, what? Security groups. I think we have already security groups created. So again, I choose my NaomTech group. Okay, I don't need default. I can remove that if needed. Okay, so these are the steps we should follow here. Again, I'm just summarizing the steps. And after that, listeners, HTTP, we have to generally choose this HTTP protocol, which is by default runs on 80, this port 80. Okay. And then what else we need to add here? We have to add a target group. So that we should create now. Okay, what is that again? So till this, the steps are clear, right? Again, I am summarizing. What is that you need to do while creating application load balancer or load balancer? What is that you should provide name? That is first thing. Second thing, you have to choose this. This is by default selected, internet facing, and then IPv4, all this. Next, after that, network mapping, by default, we choose VPC default one. And then here, availability zones, we just need to check two availability zones, right? Any 2 is fine, right? That should be okay. And apart from that, you have to choose security groups. Okay. And finally, what is that? This is by default selected. You don't need to do anything. And then what is that? You need to add this target group. This target group is very important. Why? Because this is something which adds your EC2 instances to load balancer. I think you got my statement clear, right? What target group will do, as name says, it adds your instances to load balancer or your nodes to load balancer. Understood now? So how to do that? By default, we don't have any. Then if you don't see anything, you don't need to worry. Just you can see the option on top of it here, create target group, and it will immediately open a new window. And this process still is not completed. It's in the halfway, and we have to come back again after creating target group. You got it right, friends? Following? So we are, if once you add target group, I believe we are almost done. We are ready to go and create this load balancer. So let's jump to the target group. so that we can finish the rest of the part of this load balancer creation. Okay. So now what is that here? You have to choose instances. Okay. And then target group name, of course. So that comes here as this one. I just take it as my web TG. Okay. Come here and just add that name here, my web TG. Did I add it completely? It just only selected this. Come here, add this my web TG. Okay, and then remaining things you don't need to change anything here. Keep rest of the options as is, default selected. Don't change anything, and then just got it right. What is that in this create target group? Just you need to pass add this name here, target group name. You can just leave other things as is. No more changes required in this window. Okay, just say next. And now you can see there is one EC2 instance running right now that is just created by us. You can choose this if you want. And you can add this step here itself, okay, or after creating. You don't need to do this now immediately. You can come back and do it, or you can add targets. So whichever instance is running here, whatever you want to be part of this load balancing, you can choose those targets from the available instances. You might have 10 instances. You don't need to add all 10 to the load balancer. You can choose which instances to be part of load balancer. It's up to you. But for testing purpose, I added one so that it's easy for you to understand the load balancing and scaling. So what is that? I tick this. I am adding while creating this target group itself, and I am registering the targets. Targets means what is that? The instances that should be part of load balancer. Is that clear now? Now we have one. You already know where this one is coming from. We just created. Okay. And then you can say this, include this as pending below. So now it comes to the bottom. Okay. And finally, what you can do once this is included, then you can just what you can do, create target group. Say that once you don't need to do anything. Just say create a target group. Now, what did we do with target group? We did two things. What is that? We created target group, attached instance, and also what is that? Create and completed creating the target group. You can see. And you can see total how many targets are created here. You can see it's showing one target. You got it right. And still you have zero healthy. This all these details will be updated soon. You don't need to worry. Just keep observing. Okay. You have already, you can register targets. Below that, you can see what are all different registered targets available under that group. You can see that. And if you want, you can add more to this group as well. Okay. So on this, you can do health checks, the other, and you can also do a bit of monitoring here. So you can do multiple sorts of things here. Okay. But it's okay. Right. We'll come back to all this again, right, in some other session. But this is how you have to add instances, running instances to the target groups. Now we are not done with this. What is that? We left something in the halfway, right? So this creating load balancer. Now come here, refresh it again. If needed, you just add those details again one more time. Okay. See, I think we lost all the details. No problem. Right. We just only need name here. My web ALB. I just put it there, and then right. When I repeat it, it gets registered better in the mind. Don't worry about that. So then internet facing, this is by default selected, leave it IPv4 is fine. And then default VPC, and then to what is that? Availability zone select, and then security groups. Okay. You can choose, I choose my NaomTech. It's up to you how you create your security groups. You choose that. Okay. Again, if you need any help, I'm there. Don't worry about that. Okay. And then after that, what is that I should do this time? Earlier, right? When in the first time when we are doing, we don't see anything under this target group. But now you can see my web TG is there because we created just now in just few seconds back. So that's visible here now when I do a refresh. You got it right. Now I selected target group, and finally, I think we finished the last leg of this load balancer creation. Finally, scroll a little bit down. I don't think you need to add anything extra things here, anything more. You got it right, friends. So finally, what you have to do, create load balancer. Perfect. Okay. So now this is important for you. Once you create load balancer, right? It's created. We don't need to do anything. Just keep it aside. All these like doing a cooking, right? So what do you do before you do? You put everything beside the in the kitchen, right? Beside that stove or something. Same thing we are doing right now, right? So we started cooking all this. What is that? We started cooking launch template and then AMI and then now we created load balancer. One more last is auto scaling group. Okay. Once we cook all this, then we start testing. Okay. So finally, this is okay. And one important information from this my web application load balancer is you have to use this URL for connecting. I mean, hitting this all these websites. EC2 instances. What is that? This is your DNS link. And from this, we try to hit it from outside, this link, DNS link. Of course, it is in my machine. If you guys connected to AWS, you can also connect to this. Okay. I'm just sharing this with you. Okay. So now, if you are having AWS account and if you log into root account, you can connect to this. You can try to hit this. Once I set up everything and if my instances are running, you can see some output there. That's for sure. I'm very sure. Okay, fine. Now what do you do? So this is ready. And once you create load balancer, all the users for users, we are going to share this link. Keep that in mind, friends. It's like URL for hitting your website. Understood now? And automatically it will go and try to get that web information from that EC2 instance from here, not this. I think it's getting the, if it is closed, no problem. We can take care of it. So this is about other step and important info. What is that? This DNS name is important. This is the URL we share to the users and we hit it from the web browser so that we see and it try to come and hit the website in the EC2 instance. You got it right. EC2 instance server. Now, after this, so we are done with all this, right? We created a target group. We created finally, if we go to the next slide, now you can see here. So once that is done, we created load balancer as well. We completed rest of the steps, including that pending registering targets. All this is completed, right? You should be fine. And I put that information, further information. So once created, note, you have to choose which one, that application load balancer DNS name, something like this. Okay. So, and then you have to hit it. So this is the something we try to access to EC2 instance. Suppose I can do it now right away itself. Okay. What I do is let's do one thing. Let's copy this. Okay. Come here. Go to the website, just expand this. Now I am not inside AWS account. It is assumed that it is a browser directly from outside. Okay. And we are using HTTP command. So just HTTP and then pass that whatever we are using as a DNS name and then press enter. And it's a bad gateway, means something is missing. You don't need to worry about it for now. Okay. So what is that? You can check it again. So one reason is I think it's closed. Web server is it's powered down, so it's not running. I can do one thing to troubleshoot this. Come to the instances, come here, and then connect to this. Okay. Connect to the instance. I connected. Let me just because the bad gateways, this is shut down. This is closed. Now it's okay. Now what I have to do? I have to just see that what is that? If that website is running or not. So what I have to do? Just take that command. Okay, this one. Systemctl is there, right? So what you can do is you can just check the status here. Okay. It says started. Then I'll just say here status. And you can see it's active and running. Now I try to request this. Okay. And then hit this. And you can see here. Can you see the output now? Can you see the output, friends? Why we didn't get we got bad gateways? I saw that this got shut down. Once this power off, we cannot get the output right. If the EC2 instance or server is not running, your website is inside this server, is present inside this server. So if you should get response, then the server should be running. Got it right? So that's why you can see happily the output. Suppose I am just one person, I give these links to some 1,000 people and ask them to hit it. How many people? I give to 1,000 people, right? And ask them to. Otherwise, I give to all of you and I told you to share it to some 1,000 people. Then my web server will become loading. Now, what is that I should do? For that, I have to do auto scaling. Instead of my one server, this one server serving the users, we create multiple servers and do the auto scaling so that it provides the service. So if this server is busy, response will go from the other two servers. You got my point, right? So how to do that? We are going to that step. Now we are almost at the end of that. Load balancing is successful and we also see the output, successful output coming after adding load balancer to your web server. Okay. Now after that, web server and website too, both. We did tested that as well and we see the output as well. We are good till this. And finally, auto scale. Create auto scaling group. If this is done, we are done. This concept of load balancing, auto scaling is successful. Now, what you have to do again, this topic takes a bit of time, but the process or the steps, if you follow as is, it's simple to do all this. Okay. Now, what is that you should do? Just add a auto scaling group to manage extra load coming from outside users to your website. Okay. How do you do that? Again, same strategy. Just copy this that auto scaling name here. That's all. So what you have to do? Go to EC2 instance. Sorry, console, and then auto scaling groups. Create auto scaling groups. That's what you have to do right now. Okay. So now what you have to do? Just go there. Go to the EC2. Okay. And then what you have to do? You don't need to do anything. I just have shown you right. Where is auto scaling groups? Go to the bottom. You can see here auto scaling groups. And then just you don't have anything here right now. Okay, just say create auto scaling groups and then just pass that information. My web ASG. ASG means auto scaling group. And then here you can see here. For this auto scaling group, in the very beginning, we did created one step. What is that? We created this template. You remember, right? My web template that you have to add. I use my web template too. This is what I wanted here. Okay, so we are attaching this to this to which one auto scaling group so that automatically this particular instance whatever we are attaching will be automatically scaled up or scaled down. Okay, and here you don't need to do anything, just attach that launch template which we created in the beginning steps. Okay, and then what you have to do, just say next. And here probably, so these things you can keep as is. VPC should be fine, and then availability zones, sir. Okay, you can choose one or two availability zones here. So I choose this one is should be fine. Okay, and then and balanced best effort should be fine. Okay, and then say next. Got it right? Do you want me to show again? If you want, I can show you again. You have to come to the second window. And here there is nothing much you do. Just choose the availability zone. One should be fine this time. You don't need two, right? If you add two, nothing happens. It's up to you. Okay. So we don't have a problem with that. Next step. And then what is that you have to do? So to this, what is that? We have to add a load balancer. What is that? Attached to existing load balancer. So what is that load balancer? You can choose here that. What is that? Once you say that, automatically attached to a new load balancer. Okay, yeah. And then load balancing name here. So what is the load balancing name? Just a minute, friends. Yeah, sorry. I just missed a small thing here. What is that you should do? Already we have a load balancer created. Don't create anything new. You have to choose attach to existing load balancer. Okay. Then finally, what you have to do here, choose from your load balancer target groups. Perfect. You can choose this. Okay. And then what else we have to do? Other things you can keep as is friends. So this is another step you have to follow. Just me double check here. So you can see here, attach existing load balancer. Once you provide that name, we have to attach this and then select this target group. Okay. And finally, there is one more last important thing you need to add. With that, we are done with auto scaling as well. Finally, we test it and we complete this. Okay. So this is just a small correction here. Okay. Attach to existing load balancer and come down and you can choose what is that your target group here. You can see here load balance target groups that has all that instances information for load balancer. You got it right. And finally, what you have to do, other things you can leave as is, go to the next. And then this is very important for you. What is that desired size group? Okay, specify the group of, your group size. Right here, we have to provide scaling information. You can see here. What is that? How many instances, additional instances you have to create for your web server to balance the load? You got it right? This is important. Okay, suppose minimum, generally you start with minimum one. I put two for testing purpose. And maximum, generally we add four. Generally, minimum you can put one, max four, max two. Okay, it's up to you, but I put minimum two and maximum four for testing purpose. Okay, now what else I should do? I think remaining things you can keep it as is target tracking policy. You can see here. Just one more small change. After coming here, you got it right. This group you can leave it as is. I don't think you need to make any change that. Desired capacity. Okay, make it to two. This one desired capacity and scaling. You can have minimum two, maximum four, and then target tracking policy. Okay, you can see here. So what is that here? You can just add, suppose there are multiple options here. So you can add CPU utilization based on CPU utilization, based on custom CloudWatch metric. Okay, average network bytes, all that. For testing purpose, we just do one thing. So suppose if your CPU usage is 70%, okay, and if it is increasing more, then you have to balance the load. You have to distribute the load. Once CPU hits how much percentage of usage? 70% of usage, then you have to shift the load to other instances, EC2 instances. Are you following now? So these are the steps we should update here. What is that in the step 4, configure group size and scaling. We have to choose what is that desired capacity. You just add 2 and then scaling here you just need min desired capacity 2 and max 4 and then target tracking policy. You can add here your customized policy. You can see custom CloudWatch metric, all that. Okay, but for now, for testing, I use average CPU utilization and I put my target. If CPU utilization hits 70%, then the traffic should be diverted to other existing EC2 instances. By default, when we just create this, automatically two additional EC2 instances are created for this existing instance. That is scaling. That automatically done by who? AWS itself. You don't need to worry about it. Okay. Next, here I don't think it. So these are the steps, friends. By now, you should be very clear with what I am trying to do here. And finally, all this is fine. Go to the next. Go to the next. And go to the next. You don't need to do anything here. So finally, this is our last window. We just created whatever we want for creating. What is that? ASG, auto scaling group. If this is done, we are very good to test our this thing scale, load balancing and auto scaling. Finally, we are good to go and you don't need to do anything and then just create auto scaling. That's all. Okay. Now this is also created. Understood now? Auto scaling group is also created. Then it's just getting updated. Just give it a couple of seconds or minutes, automatically the status will be available. Okay, that's about this one. Finally, we created auto scaling group as well, which is what we call ASG technically when you are a AWS engineer. Okay. Now AWS will now launch how many you can see this. This is very important point. Now you are going to see something which you don't expect. What is that? AWS will now just stay there. Okay, that slide is going away. AWS will now launch how many? Sorry, two EC2 instances automatically based on your template. So why? Because the capacity size, how much you mentioned, minimum is 2, right? Automatically it launches two EC2 instances. You didn't understand this, right? Are you sure? I believe you didn't understand. I'm very sure on that. Right? What this guy is saying here, we didn't get this. Yeah. Only when we look practically, we understand. Now, what do you do? Go to the instances, EC2 instances. Okay. Go to the EC2. And then what you can do in this EC2, click on instances. And then just refresh. Okay. And scroll a bit down. And you can see here, you can see something happened here in this window. Let me expand it a bit. This is the one what I created, right? EC2 instance, which we created together some time back, few moments back. Now these two are automatically created. You see this. Did we create this, friends? No, we didn't create it. These are coming here as a part of scaling. I didn't create them. That scaling automatically created it, added here, and used them based on the traffic. If load increases, it diverts the traffic to these instances. Load decreases, it will automatically shut them down. That's it. Now you should understand what I mean here. What is that? Once this auto scaling group is created, now it will launch two EC2 instances automatically based on your template. This template is what it is deciding here. Right? So we can see two instances. Now you should go and now you can connect it to these instances like how we did for my web server. You can now do one thing. Let's make some custom changes to that. Now we have to create our website into these servers as well. If all these three servers should provide service and load should be distributed to the servers, what is that you should do? You understand the kind of real-time saga that happens in real time. Okay, see what now open this. This is how exactly happens when, right, in a real environment. This itself is real. Again, I don't need to say this is real. Again, now connect it to this instance and see just to understand the difference. This is already connected and this just see the public IP and private IP so that with that you can easily identify which is what. Okay. Now you can see that this my web server is a 3 dot. You can see here 237. That is this one 3 dot. This is my web server. Okay. Just to make sure you don't get confused. Okay. Next I am connecting to this and then say connect. And I am connecting to which one now? Come on, buddy. Connect. Now I connected to scaled up EC2 instance. You can see here. And what is that? So you can see that 44202. Okay, I said connected to that 44202 and you can check that here. Okay, it is 44202. Now you can just create same website here as well. Okay, so just see because it is scaled up instance by default, whatever that is there in the master server, same data should be there in this. We can treat them as master and slave servers in this slave nodes or scaled up nodes. Okay, so now what you can do, just simply you can try with information. What is that? CD slash where to check if your website or data is available. You have to check in this path. If that and then HTML, check this path, come here ls, and it copied index.html. Just see say cat. Same data is copied to these servers as well. And you can see that my web server. But this is not my web server 1, right? What is this? This is actually that scaled up server 2, right? And what I do is I just try to provide some availability zones also same for this. Then I do one thing. For this, I put this as server 2. So I just edit this, edit just to get the difference from which server we are getting the response so that you get idea how this load balancing is happening. Okay. So now VI, what shall I do? Index.html. I name this as a web server 2. Okay. Or you can put IP or you can share include host name here. It's up to you. Just for testing, I just put it as web server 2, which is nothing but this one. Okay. So now what we do? Just escape. Okay. And then control, I mean, enter colon WQ. Okay. Now just cat index.html. Now you can see here web server 2. Next, similarly, what do you do? Connect it to the third instance. These two are what, by looking at that, these doesn't have names. Means what is the meaning of these two? These are scaled up EC2 instances, which are automatically created by your AWS infrastructure. You got it right. So what do you do right now? Just connect this again. And then just to see, you can just check their IP addresses to see which is what. Okay. And the IP address for this is what you can see here, 44,193. Okay. And this is 44,202. Now just try to connect this. What you can do is say connect here and then connect. And you connected the second scaled up instance, web server 3 here. And now you can just check what is that again, cd/var/ww/html. Okay. And now just say ls and you understand couple of many important things. When you just try to scale up automatically, whatever the websites that is there, that data that is there in the master server are automatically copied to the slave servers as well. Got it right? That itself is the beauty here. Okay. So now what you have to do, cat index.html. By default, it is copied from master server, right? So it's always shows my web server. I just edit it just to test it and get a clear picture about load balancing when we run the URL. Okay, when we hit the URL. So I just edit this as this one and then just escape, insert, and then web server 3. I put it as and then escape, save and exit. Now we are good. Cat, you can see index.html. Now I put this as web server 3. Now we have all these three in place. Why don't we test the load, how load balancing is shifted and how this auto scaling already by now you can see by looking at these instances, auto scaling is in place. I didn't create these instances. They are automatically created with the template what we created just now. Okay. That ASG group, auto scaling group, once we create that, and we can see that the servers are EC2 instances are automatically scaled up based on the min capacity. Got it right? Now, what do we do? Just come here and now you just observe the output. I am hitting the same URL from the master server, right? So whatever we just took from load balancer, you can see here. From the load balancer, we have this DNS name that whatever that is there, I am copying. Now I am just testing. See, already it is the same DNS or URL you can take it as just. And then what you have to do, just come here and just say HTTP and then /enter. Now you can see that it connected to this one. Now refresh it. Okay, refresh it, refresh it, refresh. No problem. You can do one thing. Come here, you refresh all this once. Okay, this instances everything. Just click on instances. Okay. You don't need to select. By default, they will be running and by default, they are doing the service. We don't need to do that. Just I just selected just to namesake. Now what we have to do, all this is fine. They are also running, right? Just check if they are running or not. That is important. Just changing that is not going to help. Another important thing is one important step we have to check is status. Okay. So what is that? I just need that system CTL status HTTPD. I believe system CTL status HTTPD. I think let me copy from here. So use sudo and paste that here and then okay, you can start it, not an issue. You say start, it will restart it again. Nothing to worry. And yeah, this is running, no problem. And just test here, same thing. Sudo and then paste. And then if you want to just check status, you can just check status here. We are almost done, friends. Okay. Just need to check and run it. That's all. This is already running. We tested this. Okay. Now what we have to do, come here and then just refresh this. Okay, again refresh it. Refresh, refresh. Actually, we should see here my web server 1, web server 2, web server 3. That's what I am looking for. Okay, let me do one thing. Let me try to connect from this window. Okay. HTTP, this should be fine. So actually, here it changes because I did test it all that. So I'm very sure about it. It has to change here. Okay, let me just exit. Okay, I do one thing. I'll try to connect this. Let's stop this. Then connect. Okay, let me start this AWS server here. Sorry, web server here. Okay, sudo paste and enter, and then started. If you want, you can check the status. I'm just troubleshooting this, just testing if this is hitting or not. Okay, so come here and then refresh it. You can see that my web server 2 is coming. Right, means now I'll try to start all the servers again. So means that is a clear proof that this is working as expected because of the because load balancer doesn't feel to divert the traffic. Sometimes it may not divert it. You got it right. So we don't need to take it as a negative thing. But earlier when I tested, it's working fine as well. Okay. If it is because we don't have too much of traffic, right? So it's fine. Let's start all this one by one and again test it one more time just for so this is okay. And again, just copy the same command here. Okay. Just to make sure the changes are added properly. So this is what is that 327, 237, and okay, both are different. Now just paste it here, enter, and then just check the status. Okay. Okay, fine. And the last one, you can just try to start because, and one more is we need to start, just connect it. Already it started, just we need to connect it to that instance, that's all. And now again, just what you can do, you can just add here 44193. I think 44193 is already running there. No. Now sudo systemctl start http started, and then let me check status. Okay. Perfect. Now let's run again test the URL. Okay, run it. And you can see this time it hit which one. So this is earlier the changes may not be affected or they are not applied properly. So it didn't work. You can see now I ran it again. It is distributed to my web service, web server 3. Again, refresh it. You can see here again. It is distributed to my web server. Again, refresh it. It is distributed to my web server. Again, refresh it. My web server 3. Again, refresh my web server. Again, refresh. So same website, but we are hitting from different servers. We are not hitting. When we hit, load balancer is distributing it to different website, I mean EC2 servers. And this is a clear proof how this load distribution happens, right? Are you following, friends? Why earlier it didn't work? Because whatever the changes we did or we made, once we restarted it, they are applied properly. That should be only reason, nothing more than that. Okay. So finally, this is about load balancing and auto scaling. Are you following, friends? Yeah, I'll send it, Sudarshan. Are you following, friends? This is load balancing and auto scaling. Clear for all of you? So we did tested. I hope you got clear picture, right? Yes, sir. No. So because I don't think we learned it in hard way. We understand with simple terminologies, every step clearly discussed twice or thrice. So finally, this should make you comfortable with auto scaling as well as what is that, friends? Stop recording. This is a beautiful